Picture yourself descending into the Mariana Trench wearing the most advanced pressure suit the military has ever built. You might expect to see a few strange creatures or maybe just endless black water. What would actually happen is simpler than that. Your lungs would collapse before you got anywhere near the bottom. The pressure down there is the highest found anywhere on the planet. Over 1,000 times what you feel standing on a beach. No suit, no hull, no technology humans have built could keep you intact. So, logically, nothing should be able to live there. Nothing should be able to survive that kind of crushing dark. If you've ever gone down the rabbit hole of deep-sea horror stories, you already know the ocean doesn't play by logical rules. It's home to sharks that were already alive when Isaac Newton was alive. Squids that rival a city bus in length. The kind of real-world gigantism that sounds made up until you see the footage. The trench isn't just the deep ocean. It's the deepest single point on the surface of planet Earth. So, if the ordinary deep ocean is already terrifying, so what is actually living at the bottom of it? To understand the Mariana Trench, you first need to understand where it starts, because it isn't where most people assume. The deepest known point on Earth sits roughly 10,935 meters below the surface. But that number is misleading if you picture the trench beginning at sea level. It doesn't. The upper rim of the trench itself starts around 5,000 meters down. Everything above that, the first 5 kilometers of open ocean, is, relatively speaking, unremarkable. A fish or a diver passing through those upper waters would have no way of knowing they were floating directly above the deepest scar on the planet. To grasp the scale, take Mount Everest, the tallest point on Earth, and imagine flipping it upside down into the ocean at that exact spot. Its summit would still sit roughly 2 kilometers above the trench floor. The gap between Everest's peak and the bottom of the Challenger Deep is that vast, and almost no one has ever seen it. In the entire history of our species, only a small handful of people have reached the very bottom, fewer, in fact, than the number of humans who have walked on the moon. So, what would it actually take to get down there yourself? You'd have to pass through every layer the ocean has to offer, each one more hostile than the last. The first layer is the epipelagic zone. Sunlit surface waters most of us picture when we think of the ocean. It extends to roughly 200 meters, and it's the only zone a human being could plausibly survive in, at least near the top of it. Below that lies the mesopelagic zone, often called the Twilight Zone. This is the same depth range where the record for the deepest unassisted human freedive was set, 214 meters, wearing nothing but a wetsuit. But that record only scratches the surface of this zone, which continues down to around 1,000 meters. By the bottom of it, pressure has increased roughly 100-fold compared to the surface. A human body wouldn't have time to register what was happening. Past that is the bathypelagic zone, stretching from about 1,000 meters to 4,000. Down here, sunlight doesn't just fade, it disappears entirely. There is no light at all, ever, under any circumstances. Temperatures hover near freezing, and the pressure at this depth is sufficient to deform solid steel. And remember, this is still only the third layer. The trench itself hasn't even started yet. At around 4,000 meters, you enter the abyssopelagic zone, the abyss, which continues down to roughly 6,000 meters. For most of the world's oceans, this zone marks the actual seafloor. This is as deep as the ocean typically gets. But the Mariana Trench isn't typical. Here, the abyss is just another layer to pass through. By this point, pressure has climbed to over 600 times what it is at the surface. It's an academic detail at this stage, since any human body would have been destroyed thousands of meters earlier. But the abyss is also, strangely, one of the most fascinating zones in the entire ocean, because this is where deep-sea gigantism starts to show off. Near the upper boundary of this zone drifts the giant phantom jellyfish, a creature whose ribbon-like tentacles can span more than 10 meters across. Sightings of it are so rare that fewer than 100 have ever been documented, which means scientists still don't have a confident estimate of its maximum size, though it's believed to weigh somewhere around 70 kilograms. Despite its size, it isn't venomous in the way most jellyfish are. Instead, those long ribbon arms work more like sticky tape, slowly snaring small prey that drift too close. Deeper still, near the floor of the Abyssal Zone, lives one of the strangest squid species on the planet. Not the giant squid, which can't survive past the mesopelagic zone, and not the colossal squid either, which stays confined to Antarctic waters. What lives here instead is the bigfin squid, sometimes called the magnapina. If you've ever seen footage of it, you understand why it unsettles people. Its arms hang at sharp, almost mechanical angles, and it has been filmed simply hovering motionless for unexplained stretches of time. Even marine biologists aren't entirely sure why. Almost everything we know comes from juveniles. Adults are so rare that a live one has never been captured on camera. Juveniles measure around 7 meters, including those strange elbowed arms, believed to be used for snagging tiny prey that drift past. Like the phantom jellyfish, it's another product of deep-sea gigantism, sometimes found drifting even deeper. At the upper edge of zones almost nothing else can tolerate. Gigantism doesn't stop at squid and jellyfish. It also reshapes far smaller creatures. The giant isopod, a relative of the common pillbug you'd find under a rock in your backyard, grows here to nearly half a meter in length. Modest compared to a human, but enormous for an isopod. They tend to stay near the upper abyssal layer. In theory, they could push deeper into the zone that comes next. In practice, almost none of them do, because that next zone is, without exaggeration, one of the most hostile environments on the planet. This is the Hadal Zone, and it barely exists anywhere on Earth except inside ocean trenches. It begins around 6,000 meters and continues to nearly 11,000, stopping only because the Challenger Deep itself doesn't go any deeper. The pressure here exceeds 1,000 times what you'd feel at sea level. Comparisons start to lose meaning at this point, but the rough equivalent would be the weight of a fully grown elephant resting on every single square centimeter of your body simultaneously from every direction. You might expect this to be where deep-sea gigantism reaches its peak, the deepest zone producing the largest monsters. The opposite is true. This is where gigantism collapses. There's a reason for that. A larger body means more surface area for crushing pressure to act on, and more internal structure that can fail catastrophically. Smaller organisms simply have less to break. And on top of the physics, there's an even harsher problem. There's barely anything to eat down here. Food becomes so scarce that growing large isn't just dangerous, it's metabolically impossible to sustain. Most documentaries skip this part because it undercuts the giant monster narrative. But the Hadal Zone isn't where gigantism peaks, it's where gigantism dies. So, what actually lives here, if not giants? The Mariana snailfish holds the record as the deepest living fish ever documented. Despite the name, it isn't a snail at all. It's a small, almost translucent fish with no scales, and a body so soft that at surface pressure it would simply collapse under its own weight. Down here, that softness is exactly what keeps it alive. Its body flexes instead of fracturing, allowing it to survive past 8,000 meters while still growing to roughly 30 centimeters long. Sharing that depth are amphipods, small, shrimp-like crustaceans capable of surviving all the way down to the Challenger Deep itself. Some have evolved specialized proteins that prevent their cell membranes from collapsing under extreme pressure. Disturbingly, others have been found with fragments of plastic in their digestive tracts, plastic that somehow made its way down to the deepest point on Earth before anything else could intercept it. Then there are xenophyophores, single-celled organisms, but enormous ones by cellular standards, growing up to 10 centimeters wide. That makes them some of the largest single cells known to science. And despite being nothing more than one giant cell, they function almost like architects down here, binding sediment and minerals into structures that create shelter for smaller organisms in an otherwise featureless wasteland. Beyond that, the Hadal Zone is mostly worms, microbes, and scavengers feeding on what's called marine snow, a slow, constant drift of dead plankton, waste, and organic debris falling from the layers far above. There's no real drama to it, no monsters fighting in the dark, just a quiet, brutal calculus of who can endure and who can't. The Mariana Trench isn't the only place like this. The Hadal Zone exists only where tectonic forces have torn the ocean floor open, forming deep trenches scattered mostly across the Pacific. There are roughly 20 of these major trenches worldwide, the Tonga Trench, the Philippine Trench, and the Mariana Trench among the most well-known. But if simply existing down there is close to a death sentence, how do we know anything about it at all? The honest answer is barely. Almost everything we know comes from a tiny number of missions, using the most advanced submersibles ever engineered, piloted by people willing to be lowered into total darkness with no real guarantee of coming back. Even nuclear-powered military submarines max out around 600 meters. That's not close. That's not even the same order of magnitude as 11,000. The first humans to ever reach the bottom were Jacques Picard and Don Walsh in 1960, inside a vessel called the Trieste. Picture being sealed into a steel sphere barely large enough for 2 people, lowered nearly 11 kilometers into absolute blackness, using 1960s engineering with no modern safety net. At around 9,000 meters, one of the outer viewing windows cracked under the strain. They continued anyway. They spent roughly 20 minutes on the bottom before beginning the long, silent ascent back to daylight. No one returned for over 50 years. Frankly, it's hard to blame anyone for that. The next descent came in 2012, when filmmaker James Cameron, the same director behind Titanic and Avatar, piloted a solo submersible called the Deep Sea Challenger to the bottom of the Challenger Deep. He described what he found as a completely alien landscape, flat, desolate, blanketed in fine gray sediment, with no large animals visible anywhere, a description that lines up precisely with everything we now understand about the limits of deep-sea gigantism. In 2019, explorer Victor Vescovo broke the depth record again aboard the submersible limiting factor, reaching just over 10,925 meters, only slightly deeper than Cameron's dive, but with a very different mission. Rather than simply touching the bottom and returning, Vescovo spent hours mapping the seafloor and filming some of the most extreme footage of trench life ever captured. He too found plastic waste resting at the deepest point on Earth. Most of what we actually know, though, doesn't come from human pilots at all. It comes from remotely operated vehicles and unmanned landers, machines lowered into the trench, sometimes taking hours just to sink to the bottom. They carry cameras encased in titanium and reinforced glass, sensors and baited traps designed to lure in anything still capable of moving. If that pressure casing fails even slightly, it doesn't leak. It implodes instantly. Even with that technology, results are inconsistent. The trench is pitch black, freezing, and the moment any equipment disturbs the seafloor, fine sediment clouds the water and ruins visibility. Most footage that makes it back to the surface is shaky, brief, and grainy, but it's enough to confirm one thing clearly. The Hadal Zone isn't empty. It's just nearly impossible to study. And so far, despite every mission, every camera, every record-breaking descent, no one has found a hidden world of giants waiting in the dark. The deeper you go, the smaller and stranger life becomes, not larger. Trenches like the Mariana Trench were never meant to be simply the deep ocean. They are something far more specific. Fractures torn open by the slow violence of plate tectonics, environments so hostile they exist almost nowhere else on the planet. They were never built to house monsters. What they hold instead is something quieter and in its own way more remarkable, proof of exactly how far life can be pushed before it has to give something up. Size, speed, even sight itself traded away one by one in exchange for survival. The Mariana Trench doesn't store the horrors of the deep. It stores whatever managed to endure. Maybe that's the real lesson hiding in the deepest place on Earth. Sometimes survival isn't about getting bigger or stronger than everything trying to kill you. Sometimes it's about getting small enough and quiet enough that the pressure simply has nothing left to crush. If this changed how you picture the bottom of the ocean, let us know what surprised you most. And if you're curious what else is hiding in the dark corners of the deep sea, you know where to find more.